So today I am going to start a new chapter, that is chapter number 14, biomolecules. Now in living organism, all the living organisms are made up from various complex biomolecules like carbohydrate, protein, lipid, etc. So in this chapter we are going to look at the structure, characteristic, classification of biomolecules. Now first group of biomolecule is carbohydrates. Now example for carbohydrates are cane sugar, glucose, starch, etc. Carbohydrate may be defined as optically active polyhydroxy aldehyde and ketone. Means in the structure of carbohydrate there will be more than one OH group present. Polyhydroxy means more than one OH group will be there, and also as second functional group that may be aldehyde or ketone. So there will be two functional group in structure of carbohydrate. First one is OH, more than one OH group, then aldehyde or ketone. So it is the definition of carbohydrate that optically active polyhydroxy aldehyde and ketone. Here what do you mean by this optically active term? Means when plain polarized light imparts on this compound has tendency to rotate the direction of light. That is called optically active compound. Basically it rotates the light. That is called optically active compound. So carbohydrates are optically active, then it must have polyhydroxy means more than one OH group and aldehyde or ketone group in it. Now next point is on hydrolysis of carbohydrate it breaks into small molecules. You can see the example when sugar, or you can say sucrose, when sucrose undergoes the hydrolysis, acidic hydrolysis, it gives us two molecules, glucose and fructose. So sugar breaks into two molecules, glucose and fructose. So that is the very important characteristic of carbohydrate. It can become small molecule. Glucose and fructose are the example. Now next point is classification of carbohydrates. First classification is monosaccharides. Now what is monosaccharide? This type of carbohydrate cannot be hydrolyzed. You can see this sugar was hydrolyzed to form glucose and fructose. Now further we cannot apply hydrolysis reaction. It will not give reaction. This glucose and fructose do not give hydrolysis reaction. It does not break into small molecule. So carbohydrate that cannot be hydrolyzed further, that are called monosaccharides like glucose, fructose, ribose, etc. Second classification is oligosaccharides. Now carbohydrates that yield 2 to 10 small molecules on hydrolysis, that are called oligosaccharides. As example you can see sucrose on hydrolysis gives glucose and fructose, two molecules are there, so it comes in oligosaccharides. Same way maltose, it gives on hydrolysis it gives two molecules of glucose, two molecules are there, so it comes into oligosaccharides. Means on hydrolysis the carbohydrate should give minimum 2 and maximum 10 small molecules. Third classification is polysaccharides. Now here carbohydrates that yield more than 10 small molecules on hydrolysis that are called polysaccharides. As example, you can see starch, cellulose, glycogen, gums, that are polysaccharides. Now further we have classification of monosaccharides also. Now this classification is based on number of carbon present and which functional group is there in the structure. So you can see if number of carbon is 3 and functional group is aldehyde, then it is called aldo for aldehyde and triose for 3 carbon. Okay, aldo triose. If number of carbon is 3 and ketone group is present, then the name is keto triose. Keto for ketone, triose for 3 carbon. Same way, if 4 carbon is there and functional group is aldehyde, then it is called aldo tetrose. If ketone group is there with 4 carbon, the name is keto tetrose. Further you can classify in compound having 5 carbon, 6 carbon, that you can do. Now we are going to discuss about glucose here. Next point is glucose. First of all, how to prepare glucose. So you can see here, this is sugar C12H22O11 sucrose. On hydrolysis, acid hydrolysis, it gives glucose plus fructose. That is our first preparation. This reaction we have discussed here only. You can see this is the same reaction. Okay, C12H22O11, that is sucrose, C6H12O6, that is glucose, and same molecular formula is there for fructose also. Now what is difference between glucose and fructose? The functional group is different here in glucose and fructose. We are going to discuss that in further points. Now second preparation, that is from starch or polysaccharides, you can tell. C6H10O5, that is a polysaccharide, starch. When it gives hydrolysis reaction H plus H2O at 393 Kelvin and 2 to 3 atmosphere pressure, it gives glucose only. It does not give fructose. N number of time we have taken here, so N glucose. That is second preparation of glucose. Now this point is very important, structure of glucose. Now here you can see this is the main structure of glucose. In that you can see 1, 2, 3, 4, 5. Total 5 alcohol group is there. CHO means aldehyde group is there. And total 6 carbon are in chain. That is the structure of glucose. Now we are going to prove this structure here. We are going to prove this structure. Okay. So first proof is the molecular formula. By some chemical method we can find out the molecular formula for glucose, that is C6H12O6. Now how does this carbon arrange itself, hydrogen, and what is the position of oxygen? That we are going to find out here by some tests. First test, that is on heating with hydrogen iodide Hi, it forms N-hexane, means normal hexane. Now you can see hexane has 6 carbon. So by this reaction we can say that there are 6 carbon in the structure. Okay, you can see the reaction here. This is the taste and this is the reaction for that taste. You can see This is the structure of glucose. When it reacts with HI, heat it gives normal hexane. So this is the proof of presence of 6 carbon in the structure of glucose. Next proof, that is glucose reacts with hydroxylamine to form oxime and adds a molecule of hydrogen cyanide HCN to give cyanohydrin. These two reactions are proof of presence of carbonyl group in it. Okay, so here when glucose reacts with hydroxylamine means NH2OH, that is called hydroxylamine. On reaction with hydroxylamine, it gives oxime, and on reaction with HCN, it gives cyanohydrin. Now these two reactions that indicates presence of carbonyl group means C double bond O is there. Now this C double bond O can be aldehyde, ketone, ester, acid, whatever. But presence of this is indicated by these two reactions. Presence of carbonyl group, C double bond O group. Now write down the reaction. You can see here, this is glucose. When it reacts with hydroxylamine NH2OH. Now what you have to do here? Oxygen and H2. You can see oxygen and H2. Remove them and form H2O. Rest of the structure you have to connect. You can say CH, CH, then NOH, NOH. Between them a double bond is there. This is called oxime. Okay. Now second reaction, that is with hydrogen cyanide HCN. This is the addition reaction. So here cyanide and hydrogen both are added here. You can see CN and hydrogen. Now in this structure cyanide and OH both are on same carbon, so it is called cyanohydrin. In previous chapter we have learned this term, cyanohydrin. Okay. Now what we have proved here, you can see 6 carbon that we got, then presence of C double bond O that we got. Now next proof, 4th number, glucose gets oxidized by mild oxidizing agent Br2 water. This indicates presence of aldehyde group. Now we have C double bond O group and we have this aldehyde group. So we can say that our C double bond O is from aldehyde group. Now you can see when glucose is oxidized with mild oxidizing agent. This word mild oxidizing agent is important here. If glucose is oxidized in presence of strong oxidizing agent, then it must have C double bond O as ketone group. But here the mild oxidizing agent is there. That's why we can say that there is no ketone group in the structure, there is aldehyde group. You can see the reaction here. CHO, this is glucose, CHO, CHOH 4 times, CH2OH. In presence of Br2 water, it gives this structure. COOH, you can see oxidation is there. CHOH 4 times, CH2OH as such. So this indicates presence of aldehyde group. Now 3 proofs we have. First 6 carbon, second presence of C double bond O, third that C double bond O is from aldehyde group. So that 3 proof we have. Now look at the 5th number. Acetylation of glucose with acetic anhydride gives glucose pentaacetate. This indicates presence of 5OH group. Okay, so here you can see when glucose undergoes acetylation, it gives pentaacetate, means 5 acetate group is there in the product. So 5 acetate is formed by 5OH group. So that by that we can say that in the structure of glucose that there must be 5OH group. Now look at the reaction. CHO, CHOH 4 times and CH2OH. You can see total 5 times we have OH group here. This one is aldehyde. 4 times OH and this one is 5th time. Acetic anhydride. This is the formula for acetic anhydride. CH3CO twice O. You can see aldehyde group remains as such. What you have to do? Remove this H and CH3CO from this structure. COCH3 you have to attach here. CHO, you can say CHO, then COCH3. Same way here. CH2O, CH2O, then COCH3. Okay, that is the acetylation reaction. You can see total 5 times acetyl group is there. COCH3 comes 5 times here. So we can say that it is pentaacetate compound. Okay. Now number 6. On oxidation with nitric acid, glucose and gluconic acid both give dicarboxylic acid. This indicates presence of 1 degree alcohol group. Okay, so now we have to find out where OH group is placed. So you can say glucose and gluconic acid, these two substances, they both get oxidized with nitric acid and give dicarboxylic acid. Now look at the structure. This is the glucose. When oxidized itself in presence of HNO3, it gives dicarboxylic acid, COOH and COOH, dicarboxylic acid. Now this is gluconic acid. COOH is there already present. And here on the bottom of this structure we have CH2OH. Now when we oxidize that substance, it also gives the same product, COOH, dicarboxylic acid. So we can say that this glucose must have this CH2OH group in it. So you can see this CH2OH is proved by comparison of these both, gluconic acid and glucose. So we can say that there must be 1 degree alcohol present in glucose structure. Now the final arrangement of OH group. The final arrangement of OH group that was given by Fischer after studying many other properties, that is you don't have to worry about. And the final structure is given this. You can see this OH is on left hand side, 4 OH that are on right hand side. Okay, so this is the main structure, final structure of glucose. So this is the proof of structure of glucose. Okay, so that's it for today. Thank you.